Hi, this is Group 1's pH Indicator Project by Zane Adams,
Jimmy Kitty here,
Jarrell Mitchell,
Matthias Hines, and I, Terai Walker.
For this project,
we are going to make an organic pH indicator
using a red cabbage.
to prove our project can be used.
As a universal indicator.
Each member in our group
did this project himself.
And each step was later combined.
To create this video.
And we did not feel like doing by each other.
First, we cut the cabbage into small pieces.
For our pH indicator, we'll be using red cabbage, and for this we'll only need about a quarter of the cabbage. After cutting it into a quarter, we'll chop it up into small chunks. The smaller the chunks, the better. Now we are going to cut it up into smaller chunks. As I said before, we're trying to make the chunks small as possible to make this pH indicator work as best as possible.
Today we come to do an experiment creating a pH indicator out of red cabbage. And to do this, you have to boil it and take the water from it and pour it in any random substances.
Then we boil it for 30 minutes.
Now we're going to take the cabbage and put it into a bowl and submerge it into hot water.
And then we let it settle for 30 minutes.
For pH indicator, we'll be using bleach, vinegar, and bottled water.
So these substances we have here today are bleach, baking soda and water, squeezy and water, and just water.
For our first test, we used vinegar for an example of a strong acid. The color was bright red, which is a pH of 1.
Next, we'll be testing the vinegar. And now the vinegar turns a dark red.
Then we used bottled water as an example of something neutral. The color stayed the same.
So I'll be doing the bottled water. And the bottled water turns a light purple.
The baking soda turn a light blue, the squeezy and water turn a darker blue, and the water just turn blue.
Finally, for an example of a strong base, we used bleach. The color was bright yellow, which is a pH of 4.
Lastly, we'll be testing bleach. And the bleach turns a deep yellow.
So now we know that the water is neutral. These are bases, and all three of these are bases.
Let's look at this a little closer. First, let's look at what pH is. pH is a scale that we use to measure acidity. The lower the number is on a scale, the more acidic the solution is. Water is a neutral solution and has a pH of around 7. Vinegar, which is one of the most common household acids, has a pH of 2.2. pH is determined by the number of hydrogen or hydroxide molecules the solution has. One of the ways scientists determine the acidity of an unknown solution is with a pH indicator. There are many different kinds of indicators, but what they all have in common is they all change color based on pH of a solution. The natural pigment present in red cabbage is called anthocyanin and is an example of an indicator. These indicators show the pH of a solution by changing color. Now, the color of an object we see depends on the shape of the molecules the object is made of. White light contains every color in the rainbow, and each color has a different wavelength. Molecules with different shapes reflect and absorb different molecules of light. The wavelength of light that reflects off molecules is one that reaches our eyes, and that determines what color we see, while all other wavelengths are simply absorbed. When we add an acid to our red cabbage solution, we flood it with hydrogen molecules, which causes the indicator to change shape and reflect red wavelengths, making the solution look red. If we add a strong base, there is instead a high amount of hydroxide molecules, causing the shape of the indicator to turn green. Solutions that are only slightly acidic or basic will change the color of the indicator to shades of maroon or blue respectively. Well, that's it guys. I want to thank you for watching our universal red cabbage pH indicator video project. Ms. Fonset, I want to thank you especially for the 100% on our chemistry project. Thank you and goodbye.